Wendy bought a new car for a total of $18,996, including sales tax. If the sales tax rate is 9%, what is the cost of the car? Now remember this from yesterday. We have a total cost. The total cost is the cost of the car plus the tax that you have to pay on the car. So we should have an X value standing for the car cost. And then to calculate the tax, you have to do 0.09 for the 9% times X to come up with your total tax paid. Now the cost of the car plus the tax you paid is your total cost. So we're going to have X plus 0.09X is going to equal 18,996. All right, well, right now we have 1x plus 0.09x equals 18,996. So I'm going to put the two x's together to give me 1.09x equals 18,996. Then all you have to do is divide both sides by that 1.09. And you're going to come out with some approximate value for x. Can someone plug that in a calculator and give me that value? Yeah. 17,427.52. And that was about, right? It should be about. Now let's read the question. The question says, what was the cost of the car? Well, we said the cost of the car equaled X. So that 17,000 actually is our answer. That is the cost of the car. Our car cost.
That's a cheap vehicle, relatively speaking. Not really.
I would say it's kind of ballparkish without having bells and whistles on it.
Like if it's like a used vehicle, that's pretty good.
Even like a new Honda Civic or something.
That's not
That's not that
that cheap.
cheap at all.
Well, yeah.
That's not cheap.
No, like if you buy like a Honda Civic
Oh, yeah.
or just an entry-level car.
How much is your car cost?
All right, questions from the homework.
Oh.
Yeah, Liam.
13.
Just say it 13. 13
and also 15.
Okay. Well, then I'll show a picture of both. Hey, we really don't have time for me to talk over everyone today, so you are going to have to stop having conversations with your neighbor right now. All right, we have, for number 13, it said S equals A sub 1 minus A sub 1 times R to the N over 1 minus R to solve for A sub 1. So your big problem in this one is the fact that you have A sub 1 and A sub 1 in two different places. So the first thing you're going to do is you're going to factor those out. You're going to factor those out in front, which is going to give you that A sub 1 times 1 minus R to the N over 1 minus R. Now we're going to treat that 1 minus R as just one thing. So you'd multiply both sides by 1 minus R to cancel those out. And you would have S times 1 minus R on that side, which I have right here. Now we have this equals that A sub 1 times that. We are going to divide both sides by that 1 minus R to the N. Divide this to the 1 minus R to the N. These will cancel out, and I'm just left with A sub 1 alone there. For number 15, I need to get D out. So the first thing you would do is you multiply both sides by that 2.37. And 2.4 times that 2.37 does give you that 5.688. Everything else is just subtracting and dividing in that one.
Okay, when you check homework,
I'm not going to check it today.
Oh, okay.
But what were we going to say?
Can you help me with it later?
Which one?
15, since you don't get it.
15. Which step?
I don't get how you get 5.688.
So you are going to, we need to get rid of that 2.
So you multiply 2.4 by
2.37. That'll cancel that out, and we're going to have 2.37 times that 2.4 2.4, if you plug that in your calculator, times 2.37 does come out as 5.688. That's where that 5.688 came from.
Okay. Sounds good.
Is that clearish then?
Yeah.
Okay, good. Hesitant hand, yes.
Can you do the last one?
Yes. All right, number 27. We are investing income where someone won a game show. The government took half of it. They invested 1/3 of the winnings to a copy shop, and then they did 1/6 of their earnings to a bakery shop. So let me show you my thought process in the order in which I did it. I will put this all up, and then I'm going to erase some stuff. So starting off this problem, I didn't put all that down all at once. Where I started was, nope, too much erasing. I started right there. I said, winnings, I don't know how much she won. She won. That's the past tense of winning, right? You won it. She won.
Wow.
She won X dollars. Half of it was through taxes, so 1/2 times X is your taxes. 1/3 of it she invested in a coffee shop, and 1/6 she invested in that bakery. Then I went a little further and went to a different problem, and I said, well, these both are investments. This one was invested at 14%. This one was invested at 12%. Since I'm investing, these both are going to be simple interest formulas. And I have the simple interest formula right at the top right. It's also in your notes. And that is your interest equals your principal times your rate times your time. So for that coffee shop, your interest is going to equal your principal. Well, all I know is she invested 1/3 of X, and it was times the rate. The rate is 14%, so that'd be 0.14 times the time, which is 1. Well, I did that for both of them. Let's magically appear it. So I did that same thing for both of them. Investment 1, investment 2. Then I went back up to the thing, and all it cared about was it said that the total of the investments equaled $4,000. So investment 1 plus investment 2 has to equal $4,000. So I just set up that equation. I said investment 1 plus investment 2, that's investment 1 plus investment 2 equaled $4,000. Now it's just simply solving for X. And if you looked at the answer key, this is one method to solve for X. The OR is just another method to solve for X. All right, they'll both get you the same answer. There's different methods. One is pulling out the X, getting rid of fractions. The other one's more or less getting rid of the fractions first and combining stuff later. Neither one's necessarily harder than the other, but they're both fine, I guess. Yes?
For this one, why isn't it just like 4,000 and then like you double? No. Okay, so the 1/2 of her game show winnings
Goes to
is
taxes.
equal to the amount that she invested in both things.
Mm-hmm.
Okay.
But each one, so you can't divide that in half because she didn't do 2,000 in here, 2,000 in here. Nor do they each have the same return. If they both had 14%, then you could think about halving stuff and doing it that way. But
Yeah.
we don't know how much she invested different than half, and they're different percentages. I don't know what your question is for sure, so I'm hoping somewhere in there is an answer.
Yeah, okay.
Are you okay?
Yeah, I think so.
You sure?
Yeah.
Okay. You sound very unsure of that. All right, other questions? That wasn't a question, that was a grunt.
Oh, I have a question.
Yes.
Just why is F minus 32 times 5 nines instead of F plus 32?
Say that one more time, I'm sorry.
Just number 3.
Okay, number 3. Let me take a picture of it so I can show you the intermediate step. So the thing is with number 3, we have to do our subtraction and addition first. So you would have to subtract 32 first. So we would subtract 32 from both sides. That would give me f minus 32 equals 9 over 5 times the Celsius. Now, to get rid of that 9 over 5, I have to multiply both sides by 5 over 9. But that means I need to multiply the entire left side. That's why it's the whole quantity, f minus 32 times 5 over 9.
So you don't multiply by 5 over 9 first?
If you'd multiply by 5 over 9 first, this is exactly what would happen. Let me erase this real quick. So if I decided to multiply by 5 over 9 first, so that is by this whole thing, right? We would get 5 over 9, f. We would get equals c, but we'd have to distribute it to that. So we'd actually have plus 5 over 9 times 32, in which case you have to do that multiplication, subtract. Yeah. This is just more simplified than, if you came up with that answer, it'd just be this distributed. Okay, getting into today's lesson. So we are getting into more complicated word problems. All right, they fit in different boxes. And the easiest way to tackle these problems is to write yourself a nice little table. And each of these types of problems work with a 4-column table. All right, let's start this one off. So this is a group hike down into the Grand Canyon, and it took 3 hours and 30 minutes. They returned on a trail that was 4 miles shorter and hiked 2 miles per hour slower and took 1 hour longer. What was their rate going down? I read that and I see a whole bunch of, we have rates, we have times, we have distances. This is what I call a distance kind of problem. And as soon as I have a distance type of problem, I'm going to immediately think of, well, distance always deals with distance equals rate times time. All right, d equals r times t. These are going to be the formulas we're going to set up. So in my little table there, I'm going to come 3 columns. I'm going to have a distance column. Our distance actually equals rate times time. So I'm actually constructing several different formulas, but I'm putting in a table so I know what I'm filling in rather than having to come up with formulas off the fly. So going back to what they talked about, they said they go down the Grand Canyon and then later they come back up. So we need 2 categories here, a down and we need an up. We need a going down and a going back up. Let's use the information they give us as they give it to us. So the first bit of information they give me is a group hiked down the Grand Canyon. It took 3 hours and 30 minutes. So we have a time for our down. I'm not going to write 3 hours and 30 minutes. Instead, I'm going to write 3.5 hours. Now I'm going to see what going up took, if they give me any information about going up. I'll use the same thing. So it says it took 1 hour longer to go up. So since it's 1 hour longer, it has to be just 4.5 hours. There's no reason to put 3.5 plus 1 there because that's kind of a waste of time. It's just 4.5. All right. They returned on a trail that was 4 miles shorter. Let me highlight that really quick. They returned on a trail that was 4 miles shorter. Nowhere else in there did they talk about the lengths. All we know is the return trip was 4 miles shorter. So we actually have no idea how long it took for them to go down distance-wise, but we do know going back up was that same distance minus 4. This is, the distance was, if this was 10, this would be 10 minus 4, it'd be 6 miles going back up. So this matches. They return on a trail that was 4 miles shorter. 4 miles shorter just means it's x minus 4. Now let's see what information they have about the rate. It does say that they... Nope, wrong one. Let's go red. On their return, so they returned, and it was 2 miles per hour slower. So the return was 2 miles per hour slower. Once again, they did not comment on how long it took to go down, so let's call it y. So the going back up must be y minus 2 miles per hour. This is 2 miles per hour less than this one. All right, like I said, these were just to set up equations for us. Our equations for this one are going to be, well, x, for the top one is x equals, well, it's 3.5 times y. For the bottom one, we'd have x minus 4 equals y minus 2 times 4.5. Right? Because we have distance equals rate times time. The only thing I did, I flipped this around because usually we put the 3.5 in front of the y. But I'm just pulling it right out of here. All right, now we have two equations with two variables to solve. We can either graph it. Don't graph it. That sounds like a terrible idea. We could use substitution or we could use elimination. Which one probably sounds better in this case? Say graphing. Say it, I swear. No, what do you think? Substitution is going to be the best one. Because all we have to do is say, well, if x equals 3.5y, we just need to plug that in there. I'm actually going to complete this. I guess I can go straight down. We can go, well, that's 3.5y minus 4 equals, I'm going to go ahead and distribute this 4.5. So we'll have 4.5y. 4.5 times 2 is going to be 9, so it's minus 9. I'm going to go step by step. You can get ahead of me. Feel free at any time. Let's go ahead and add 4 to both sides. That'll give me 3.5y equals 4.5y minus 5. Subtract 4.5y from both sides. And we are going to have a negative 1, y equals negative 5. Let's go this direction. We just have y equals 5. Here's where we read the question. Because I can definitely plug 5 back in for x equals 3.5y and say my x equals 17.5. However, I do not need to find x. Nowhere in this equation does it say you need to find x or y. The question is, what was their rate going down? So you go back to your table, look for your rate going down. That is just simply y. So if y equals 5, then our rate going down must be 5 miles per hour. And that's all they asked. For all the information that we have missing, that's all they asked for. All right, continuing on. The next one looks very similar, but it's going to have a little bit of a twist to it. We have Shelley drove 40 miles from Peoria to Bloomington. So as soon as I see someone's driving, I'm immediately thinking distance equals rate times time. I'm immediately thinking that, and I'll immediately fill in my table, distance equals rate times time. I know it has to be that way. All right, Shelley drove 40 miles per hour from Peoria to Bloomington at 20 miles per hour. So we do have one thing. We are going from Peoria to Bloomington. Well, that says she drove back more quickly, so her average was 30 miles per hour. So she has to return. So she has to go from Bloomington back to Peoria. And here's where the change comes in. It is a sentence right here. Her average was 30 miles per hour. Since we're looking for an average, we also have to look for a total. Our total distance is going to equal our average rate times our average, or times our total time. Where's my line tool? There we go. And you'll see why we need that total in a second. All right, let's go back and start filling some information in. The first thing is Shelley drove 40 miles from Peoria to Bloomington. So we have 40 miles from Peoria to Bloomington. Now, they didn't say she took a different road home or anything, so we can assume that coming back also was 40 miles, which means our total distance would be 80 miles. All right, rates. It says that Shelley drove 40 miles per hour from Bloomington at a rate of 20 miles per hour. So we can put a 20 in for this one. It also says her average was 30 miles per hour. So our average, after all said and done, is 30. Spoiler alert. The answer is not 40. The answer is not 40. The only way the answer would be 40 is if she drove 20 miles per hour for half the time and 40 miles per hour for the other half of the time. Since it's distance, she's going to drive 40 miles an hour, or she's going to drive this fast speed a lot quicker than she drives this slower speed. So it is not just doing finding your average 20 plus something divided by 2 equals 30. That is not the answer to this one. So if you put 40 in there, that is wrong, and we'll see that the answer is completely different. So we know nothing about the return speed, or from Bloomington to Peoria. So we're going to put an X there. Although it doesn't directly talk about time, it does give us several of our times, or at least information about it. And that is because since our formula is distance equals rate times time, we can solve for time by dividing rate from both sides. So I can rewrite this formula as time equals distance divided by rate. So in this first example, our distance is 40 miles, and our rate was 20 miles per hour. So the miles would actually cancel out, and we left with 2 hours. Well, although we don't have definitive numbers to fill in here, our time is still going to equal our distance, which is 40, divided by our rate, which is x. So this is going to be 40 divided by x hours. Now, since this took 2 hours, let's say this took 1 hour. It'd be 2 plus 1 equals 3. So this 2 hours plus that 40 divided by x, whatever that is going to be my total time. So we're going to have 2 plus 40 divided by x. Now we do have 3 equations here. If I would, let me highlight as I'm saying it, if I would actually solve this equation, it would be 40 equals 20 times 2. You just put, yep, that is true. It's not really solving anything. Our next one would be 40 equals x times 40 divided by x. X would cancel out. You come up with 40 equals 40. Once again, it would just be, yep, I agree with that. So none of those are that useful except for that last one. That last one is the only useful one to actually pull out. So we are going to take that last one and we're going to rewrite it either to the right or down below. I don't care. We have plenty of room on both sides. So I'm going to have 80 equals 30 times 2 plus 40 divided by x. Once I solve for x, I'll be able to find all those missing bits of information. So we have 80 equals 30 times 2, which would be 60, plus 30 times 40. Well, 3 times 4 is 12. We'll have 1,200 over x. Now it's simply subtracting 60 from both sides to give me 20 equals 1,200 divided by x. Then I would go ahead and multiply both sides by x. Let's continue that guy. Hey, let's go over here. There we go. We are going to have 20x equals 1,200. I want to make sure I didn't mess anything up before I finish everything off. Nope, we are okay. We're A-okay because we came up with x equals 60. As soon as I come up with x equals 60, we can now solve here, here, and here. We can solve every one of them. Let's see what the question is to see what we answer. It says, what was her return speed? So her return was Bloomington to Peoria. So her return speed would just be x. So whatever x is her return speed. So her return speed would be 60 miles per hour. That is not 40 miles per hour. So it would take her about 2/3 of an hour to drive back. All right, so do not, if I put this on the test, do not just go, oh, this is a super easy question. 20 plus x divided by 2s equals 30. That is not true. That only works if I was driving this for 2 hours and then driving this one for 2 hours as well. Then your average speed would come out to that. Only if you're driving the same times. All right, let us push on. All right, any questions on this one? I'm sorry, before I just kind of crush through. So I just want to reemphasize the difference between these two. This one only gave me information from the trip down and up, so I didn't need to have a totals column. This one gave me very specific information to the total trip with our rate, so I did have to put a total in here. All right. Generally speaking, the only one that really affects having to have a total column would be that rate right there for our distances. All right, our next one. This one is what we're going to call a mixture problem. I think I have room to do that there. It's a mixture problem, and they show up. So whenever you see a mixture problem, you're going to solve it the same way every single time. It will always work out this way when we're doing a mixture of things. So we have a producer makes orange drink, which is 10% juice, and orange delight, which is 50% juice. How many gallons of orange delight must be mixed with 300 gallons of orange drink to create 40% juice solution? Whew. All right. Let's disseminate this information into a chart here. So the first thing I'm going to look at is, so it said orange drink is 10% juice. So the first column might be just percent. How much percent is juice? If we keep reading, they start talking about gallons. So we're mixing one whole juice with another juice to create some super mixed juice. So let's just have a column that says gallons. Now I want one more column. I want one more column. If I have a percent column and I have a gallons column, you better bet at some point you're going to multiply these together to get your last row, because these do have to be equations. So this is the percent of juice. So if this was like 10%, this is how many gallons you have. This is going to be the amount of juice. This is going to be the amount of juice. So this gallons, in fact, I'm going to switch this to just amount of liquid. And this last one's going to be amount of actual juice. And now obviously we have that orange drink. We'll call it drink. We also have that delight, orange delight. And since we're mixing, there must be a mix. Some kind of mix. It's kind of like our totals column like we did just before.
So David, do you like that orange drink?
Sure. Unless it's 10% juice, and who knows what else is in it. All right. So orange drink, let's highlight this. Orange drink has 10% juice. So it's 10%, or 0.1 when we actually do the conversion. Our Orange Delight has 50% juice. Then let's go down. We want to create some kind of concoction that has 40% juice solution. So our mixture is going to be 40%. All right, now let's go down our amount of liquid. Well, they mentioned 300 gallons somewhere in there. They said 300 gallons of orange drink. So we're mixing 300 gallons of orange drink with some amount of Orange Delight. So we are going to have 300 gallons and some amount of Orange Delight. We don't know how much. That's actually what the question is. So our total amount when we mix it, well, it's 300 plus whatever X is. So our total amount will be 300 plus X. Although they don't talk directly about what our amount of juice is, we can calculate it from this equation. If I have 300 gallons of this orange drink, only 10% of its juice, to find out the amount of juice, you are just going to do 0.1 times that 300.
Wait, why is 0.1?
Because it's percent.
Oh.
So we move the decimal place 2 places. In other words, 10 divided by 100. So we are going to have 30 gallons for that. Although we don't have a definitive value here, it is going to be 0.5 because it's 50% times X. So 0.5X. Now, if I have 30 gallons, I have a certain number of gallons. When we add that together, that's going to be our total amount of juice that's actually in this concentrate. So we'll have 30 plus 0.5X. Once again, we have 3 different equations. We have one running across here. We have one running across here. And we have one running across here. In fact, our equations are all going to be the percent times the amount of liquid is going to equal our amount of juice. If I do this here, 10% times 300 equals 30. Once again, that's just yes, if you'd rewrite that. Our next one is 50% times X equals 0.5. Once again, yes, that's true. The only one that's actually solvable is this one right here. So we're pulling out our total column once again. Yes, Liam?
Will that pretty much always be the case that the bottom one is the one that you have to...
Yes, when we have a sum like this. The only time it might be different is if we have down and up only. Then you have to use both of them. But usually if you have any kind of mixture or something that you have a total, it will usually almost always be that total column. All right, so our total column would be 0.4 times 300 plus X is going to equal 30 plus 0.5X. And now it's just solving for X. So you can either follow along with me or just go off on your own merry way. All right, we have 0.4 times 300, which equals 120. We have 0.4 times X, which would be 0.4X. That's going to equal 30 plus 0.5X. Well, let's subtract 0.4X from both sides and then subtract 30 from both sides, which would give us 90 equals 0.1X. We are going to divide both sides by 0.1, which is actually going to turn into X equals 900. I'm going to circle it, even though I don't know what's the answer. It's something important. So I'm going to go to the question. The question says, how many gallons of Orange Delight must be mixed? So we go up to our table and we look for where is Orange Delight and amount. Well, it's right there. So X is my answer. We're going to have 900 gallons. every mixing problem sets up the exact same way. Mixing problem should be pretty easy because it is just kind of plug the information in. In fact, all of these are kind of make your table correctly, plug in your information, and go from there. Any questions on this table that I created? All right, then we just have one more, and it's one more big one. This is going to be our work one. I always call it work because we're applying some kind of work. I want to move that over just a little bit because I'm going to put something there. This is the one that's just like Bill can paint a house in 24 minutes. Steve can paint a house in 36 minutes. They get together and paint one house. How long does it take? That is this type of question. We are getting work done. Whenever I read a work question, it is strongly related to distance. Remember, distance equals rate times time. Well, work is very, very similar. It is going to be, and this is what I'm going to put in my columns, I'm going to put speed times the time I work. So how fast I work times how long I do that work equals how much work I actually get done, or number of tasks, or whatever you want to put in that column. How much I get done. All right, now let's read the question. So, aboard this ship, Brett can process the crew's medical history in 36 minutes. An android can complete the same task in 24 minutes. 1 minute after Brett began processing, the android began as well, and they worked together to complete the task. So together, they completed one medical history. Here's what's going to be really important here. First, let's make our two columns. We have our two rows. We have Brett, and we have a robot. Here's where these can get tricky. Note it says that Brett can process a crew's medical history in 36 minutes. This is actually a rate or a speed they're giving us. They are saying he can complete one task in 36 minutes. So in other words, one of those medical histories per 36 minutes. That's what that statement says. You have to create this fraction. So in the speed, he can do one task per 36 minutes. And the android, likewise, can do the same task in 24 minutes. The android is going to be 1 over 24. Now we'll go to time. Time says 1 minute after Brett began processing, the android began to work as well. So that means if Brett works X minutes, the android is going to work X minus 1 minutes, and that is because he started later. Some of you may do it this way. Both ways will get you the same answer. You can also say if the android works X minutes, then Brett worked X plus 1 minutes. As long as somehow you show me that the android works 1 minute less. Both ways do it. I always do it with the subtraction. Some people always do it with the addition. All right. Now this is an equation, so we can actually get this work total done on this column. So for work, we're going to have 1 over 36 times x. And for bottom row, we're going to have 1 over 24 times x minus 1. Now here's where I have to reread the question. They said they completed the task. So the task must mean they completed one medical record. Make sure you read that part, because I can say, how long did it take them to do 2 of them? How long did it take to do 3 of them? Or how long did it take to paint 4 houses, or whatever it is. This one just says one task. Well, however much work Brett does, plus however much the android does, when combined, they have to equal one task complete, one medical record. So our equation for this one is going to be 1 over 36 times x, so the amount of work Brett does, plus the amount of work the robot does, is going to equal 1 medical history. So it's just one of those medical histories. Maybe I should put medical history. Well, the first thing I'm going to do is clear those fractions. To clear those fractions, I'm going to multiply by 72. 72 divided by 36 is going to equal 2x. 72 divided by 24, well, that's going to equal 3. So it's plus 3 times the quantity x minus 1. Don't forget about multiplying 72 by the 1 as well. So that's going to equal 72. And now it's just simplifying. 2x plus 3x minus 3 equals 72. 2x plus 3x is 5x. Add 3 to both sides. We have equals 75. Then we're just going to have x equals 15. Here's where people are going to get these problems wrong. They're going to say x equals 15, and you lose at least 1 point on the test. That's 1 out of 4 you're going to lose by saying x equals 15. That is not what the question asked. The question asked, how long did the android work? Brett worked X minutes, so Brett worked 15 minutes. Brett worked 15 minutes. But the android worked 1 minute less, so that'd be 15 minus 1 minutes, or 14 minutes. Don't get this wrong. Read what the question says as soon as you solve for a variable, and make sure you're answering that question. Do not just circle x equals 15 and go, that's my answer, I'm good. All right, really, really quick, because we don't have that much time. I want to go through your homework really quickly. First of all, do you see that number 5 and 6? You don't have to do those two. You don't have to do the two. Those are basically the exact ones we did in class. They are practice if you want to do the exact same things. Like they're almost the same problems verbatim if you just want to practice ones that are basically the same. Number 29. Number 29 is not going to be one where you need a table to solve. It is more like that one from yesterday where they were had that pit that was like 3 times plus 40 yards longer than the width. It's going to be that similar problem. The rest are ones that would be nice to have tables. For number 33, that hint is imperative to actually solve that problem. The hint I gave you was Bobby does 8 miles the same time Rick does 10 miles. So it's Ricky Bobby. But you're going to want to set both their distances the same because they're doing the same race. But you are going to set Bobby as only having 8 miles to Rick's 10 miles in that table. You should have an 8 and a 10 in that table. It's the only way to solve it correctly. The rest are mixture type problems, same ones we did. I did come up with tables for every one of them on the answer key. So hopefully you can work through them. Work as hard as you possibly can on these. All right, tomorrow's going to be a lot easier. It's just midpoints and distance formulas and plotting points. And then we'll graph some lines. So this is probably the hardest part of the chapter, so get it done, work hard. And have a wonderful Thursday.